Alrighty, so let's look at the first question. We have dice. There's two of them. What is the probability that the sum of the two numbers is a 5? So how can you get a 5 when you're rolling dice?
3, 2, 4, 1.
So 1 and 4, 4 and 1, those are different things.
Right.
And then 2 and 3 and 3 and 2. Those are the only 4 ways that you could draw, that you could throw a sum. These add up to 5. Do we understand that part? Mm-hmm. Now, when you're rolling 2 dice at the same time, how many different outcomes do you have?
12.
Not 12, 36. Because there is 6 from the first one and there is 6 from the second one, so there is 36 possibilities. Now, how many give you a 5?
4.
4. 4 out of 36, which reduces to a 1/9. Are we okay with that?
1. That's it.
Yes. So that, is there any questions on that explanation? No? There's a bag with 16 balls. They're numbered 19. They're numbered 1 through 19. What is the probability of selecting a ball that has an odd number? How many odd numbers are there from 1 to 19? And if you're not sure, we are looking for the probability of a 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. What are the probabilities? And Manuel says 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of how many?
10 out of 19.
19. Can you reduce that?
No.
Nope. This is your answer. There's a card from 52 card deck. What is the probability that the card is not a 10? Well, how many 10s are there in a deck of cards? 4. So how many are not 10s?
113.
48. 48 out of 52, which reduces. So 48 out of 52 are not 10s, not 10 out of 52, and it reduces to 12 over 13. So we need to be able to read to understand what's going on. Now this is the expected value. So suppose you're supposed to pay $2 to roll a fair die with the understanding that you would get $6 for rolling a 6 or a 2. What are the chances that you're going to draw a 6 or a 2 without simplifying your fractions? But it is 2 out of how many? 6. So it's 2 6 times, how much money would I get?
$6.
It says what?
$6.
$6. Minus or plus, otherwise you get what? Nothing. So you get nothing for all the other 4 out of 6 possibilities. So what is 2 6 times 6?
2 6 times 6.
Is what?
It's going to be 12 over 6.
Which is? 2. What's 2 minus 0?
0.
It's $2, right? Now this is how much you could win, but how much did you just pay for your ticket?
$2.
So do you really make any winnings?
No.
2 minus 2 is 0. Your winnings are $0. Now, if my ticket would have been just $1, then at least you would have made $1. This one. So as soon as the person spins a pointer, and there was supposed to be a pointer here, you spin it, and you're awarded the amount indicated wherever it lands. So how do you find out what is a person's expectation? So a person is expected to win $9. How much?
1/4.
1/4, right? 1/4 times 9 plus, you make $1 for also 1/4 minus, or you could actually, you could put
1 half.
You could put a plus 1/2, but because this is a -2, a -7, or you could put minus and make sure this is a +7. But because of the way, and I think I did it differently in the notes, but you could put plus the 1/2 of the 7, but it's a -7. Now this becomes 9/4. This becomes a 1/4. And this becomes -7/2. -7/2. Now, can I add these two fractions?
Yes.
But before I continue, are there any questions on those fractions right there? Does everybody understand where the 1/4 and the 9 and the 1/4 and the 1?
Denominator now?
We can, or as soon as I add these, I'm going to be able to reduce. Now, this becomes what? 10/4, and 10/4 reduces to 5/2. Can I subtract those? What's 5 minus 7? -2/2, which is a -$1. Because we're talking about money. So how much are they expected? A -$1. Is it worth you playing on this roulette?
No.
Not even. A restaurant has offered a salad, 2 types of dressing, 3 different toppings. So that means you can put lettuce, cucumber, or pick tomatoes, whatever. How many different types of salads can be offered? 2 times 3, which is 6 different types. This is like that points. That's the way you would ask how many different points.
I like the tree.
The tree thing. So 6 different salads, just in case. Alrighty. Anything else on this question on this page? So test. I don't think it's going to be that difficult. Question.
Yeah, on number 5,
Uh-huh.
if you would have found the common denominator, would you have still ended up with the same answer?
Yes.
Okay.
So do you want me to do it that way, just so you
No,
see?
I know how to. I was just making sure
No, you said
that I
it's
could,
same.
like, I'm used to doing it that one way, so like,
So let me just
I know that when you showed us was easier, but
let me just do it. This becomes 9/4 plus 1/4. The common denominator here is times what? 2
14.
minus 14/4. 9 plus 1 is 10. 10 minus 14, -4/4, which is still a -4. Still get the same answer. Alrighty, next page. There are 3 balls in a hat, one with the number 2, one with the number 4 on it, and one with the number 8 on it. You pick a ball from the hat at random, and then you flip a coin. Using the tree diagram, obtain the sample space of the experiment and list the elements that make up the sample space. So the first thing is you have how many different things? 3. A ball that has a 2, a 4, or an 8. So this is the ball. But then you're also going to do what? Flip a coin. Each coin has how many possibilities? 2. It could either be a heads or tails. Heads or tails. Heads or tails. So what is your sample space? 2H,
6.
2T, 4H, 4T, 8H, 8T. There is 6. And it says to list the items, so make sure you list them. Questions on that one? No? Now, number 8 and number 9, it's the same question, except one of them says without replacement and one of them says with replacement. That's just it. So the first one says you have 3 cards in a hat, 1 a king, 1 a queen, and 1 an ace. 2 cards that are selected without replacements. So what are my first 3 options? King, queen, and ace. Very good. So it says you're going to select another card, but there is no replacement. So if there's a king, I can only get what or what? a queen, or an ace. There's no more kings in there because you're not putting it back. The queen could either become what or what? King or ace, and the ace could become a king or queen. So who's your sample space? KQ, KA, QK, QA, AK, AQ. Again, it's 6 because you first have 3 and then you have 2 options. But the next one, again, have 3 cards, but there is replacement. So even though you grab a king, you're going to put it back, and there's a possibility that you're going to, what? Grab another king. So we're going to start with those 3. King, queen, ace. So my second time drawing a card, it could be what, or what? And you're going to have to draw these little tree diagrams for the questions that you get. And the list. I need to see your work. So if anything, it's just time consuming. So this becomes KK, KQ, KA, QK, QQ, QA, AK, AQ, and AA. Now I have how many? 9. 3 and 3. Any questions? No. There are 3 balls in a hat. One is 1, one is 2, and one is 5. So that's the first thing. 1, 2, and 5. But then it says that what could happen? What's the second thing you have?
Roll a dice.
You roll a dice. Now, how many sides are there in each dice? 6. So from each of these, I have to do 6 lines. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. Now, this one's going to lead into another question. So I'm going to list 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, and 5, 6. Now, after you do your sample space, which has been very similar to the other 2 questions, but this one has a second part. It says, find the probability that the number on the ball is greater than the number on the dice. So is the number in the ball, which is the first one, ever greater than the one on the dice?
Yes.
For the first section?
No.
No. For the second section,
Yes.
only how many times?
2.
Once. That's it. How about here? How many times with the 5? How many times is the ball big? 1, 2, 3, and 4.
Would it be 5 over 18?
Is it going to be 1, 2, 3, 4, 5? 5 times out of 18. That is correct. Yes. So that would be your answer for that one. So some of them have not just write out the sample space, but there's going to be a question that follows. So you guys need to make sure you read all the way through. Oh, tree diagram. I'm just doing the little thing. Make sure there's not a second part to it. All right. Are we good? Yeah. So do number 11 on your own really quick. See what you come up with. So we have already done the sample space for this, right? We did it in one of the previous questions. Yes, we did. Oh, no. Now go ahead and answer the question on your paper. Find the probability that you would choose the same card. Write it down. Don't tell me. Not yet, please. Not yet.
Do you simplify?
If possible. Same card, same card, same card. 3 out of 9, which reduces to 1/3. 1/3. Always reduce if possible. Questions on it? No? We're good. It's gonna be an easy test. You guys freak out.
Works harder than
I know, but I would never purposely hurt you like that.
So if we pass this class, drinks on you, right, after this semester?
Margaritas.
Anyways,
They're
what
old enough to
beautiful,
drink.
beautiful video being recorded here. Yeah. Yes, exactly. A card is drawn from a shuffle card of 52 cards. What is the probability of you drawing a face card or a 4? So first of all, I don't know if you remember, and the formula is back here for this one, which is this one. When it's the OR, is the probability of A plus the probability of B minus the probability of A and B. So probability of A,
So are you gonna put all these on?
yes,
the board
that's
for us?
it's going to be on your test,
Okay.
probably. Probability of A and B. So what is the probability of having a face card out of a deck of 52? Which ones are your face cards again? Jack, Queen, and King. It's 3 times 4, which is 12. 12 out of 52, right? 12 out of 52, and then how many are 4s? 4 out of 52, minus the probability that both of these, like, they're the same section. Like, there's a 4 and a face card. Is there?
No.
You cannot have a face card and a 4 together. So this is minus 0. So this just becomes 16 over 52. It's reducible by 4. 16 divided by 4 is 4, and 52 is 13. Now, there's a lottery ball. This one, if it would have said a face card and a red card, then you would have subtracted how many? How many face cards are red? 6, right? 6 out of 52. So then this would have been minus 6, and this, of course, would have been different. But it's because I think I may do one, because both of these ended up being a 0, so I might give you an extra one right now just to have practice so you see it. A lottery game has balls 0 through 9. Now, in these problems, they consider 0 to be even. Just giving you a heads up. They do. What is the probability of selecting an even number? So which ones are my even numbers? 0, 2, 4, 6, and 8. So that is 5 out of?
No.
Not 9, because I have 10, because 0. Plus the probability of a 5 is what? 1 over 10, minus the probability that 5 is also an even number, that is 0, right? So when I add these, what does this become? Shall we review right there? Yes, it's 6 over 10, and that right there reduces to 3 over 5. You are dealt 2 cards without replacement from 52 cards. Find the probability that both cards are black. So first of all, what is the probability that the first one is a black? How many total blacks do you have? 26 over 52. Now it says without replacement. So if I'm already taking out 1, how many cards are left?
25 over 51.
25 black ones out of 51. And remember, when we do this question, it's more like we're telling you, yes, there is going to be
A big number.
a big number. Like, yes, the first one you get is a black card. Now, what is 26 times 25? 650 over 52 times 51. 2652. All I can think of right now is I can reduce by half, divide that by 2. 1346, 650 divided by 2 is 325. Do you think I can reduce that again?
Yeah.
By what? Can I divide this by 3? Nope. 325
5.
by 4?
No.
So maybe, I don't know.
6.
13. I know I could reduce it, but can 1326 be divided by 13? Yep. So 325 divided by 13 is 25. And 1326 divided by 13 is 102. So that's how far we could take it. Usually when it's problems like this, it's going to be a 4 or a 6 or a 13 because you have 4 decks of 13 cards each. 2 marbles are drawn without replacement. Once again, you're not putting them back. There's 3 white, 2 green, 2 blue, 2 red, 1 blue. Find the probability that both are white. So first of all, what are the chances the first one is white?
3 out of 2.
How many?
8.
8. What is the probability the next one is white?
2 out of 7.
2 out of 7. And this becomes 6 over.
56.
Could this be reduced
Yes.
by 6? 56 is not divisible.
By 2.
By 2. 56 divided by 2. 28. 6 divided by 2. 3. Could those be reduced? Nope, that's it. So I need to use a calculator. For this test, you will have to calculate the entire time. All right. So 2 are, it's the same thing, but the way they ask the questions are different. What is the probability that the second marble is red, given that the first one is white? So this is the one where we use this formula. You remember? First, we need to make sure if event 1 happens, that event 2 is going to happen. So what is the probability that the first marble is white?
3 out of 8.
3 out of 8. So that already happened. So how many marbles are left? 7. So out of those 7, how many of them are red? 2. So the probability that you have a red, knowing that a white already came out. So all this helps you is kind of reduce. Second marble is blue, given that the first one is white. So once again, the white one is, so we take out 1 white, there's only 7 left over, and there is how many blues? 1. So it is 1, 7. Now, let's see if you could do C.
0.
Because what happened?
The first marble,
Yeah.
Very good. So this one says, what is the probability that the second marble is blue, given that the first one is blue? Well, first we need to make this happen. 1 out of 8. And if there's only 1 blue and you already took it out at the beginning, can you do it again? No. So this one's going to be 0. Now this one's a little bit different. What is the probability? Because it doesn't say given. So you don't do it like the first 3. Both marbles are white. But what is the probability that the first one is white? 3/8. And we're not putting them back. What is the probability that the second one is white? 2/7. We multiply 6 over 56, which reduces to 3 over 28.
So how you got the second one? You got 2/7. It was basically because you had to add the first one to the one.
Because you already took out this one.
Uh-huh.
You already took out 1 from the white, and there's only 2 left that are white. 2 out of the 3. Now, how do you do E? I'm gonna have to add this one. Wait, hold on.
3, 1 over
So the probability of a white and a blue. What is the probability of there being a white?
3 over 8.
3 over 8 times the probability of there being a blue? 1 over 7, which becomes
4 over 56.
3 over 56. Can we reduce this? No. "17, this was part of your notes. Try to do it on your own. Just see what you would come up with. And there's the formula you would use. There is the formula. I haven't even worked it out. Let me see.
So can I probably do it?
Well, that's what I asked y'all, to work on it right now before I work it out. Oh my gosh. Okay, have you tried them all or not yet? Still working on 1 or 2 or 5? Oh. What is the probability that you're gonna get a 4 from a deck of cards?
113.
4 out of 52. Plus, what is the probability that you're gonna get a 7? Also 4 out of 52. What is the probability that a 4 and a 7 are the same cards? 0. So this just becomes 8 over 52, which reduces to 2 over 13. So you need 1 and 1, and then that some of these cards are overlapping.
So when it's not possible for the cards, you do -0.
You do, it would be -0, yes. What is the
So you
probability?
just add the top numbers, not the bottom.
Same, when you have the same denominator, you just work with the top. What is the probability of getting a queen? How many queens in the deck of cards?
452.
4 out of 52. How many cards are hearts?
13 out of 50.
Very good. Now, how many of these hearts are queens? 1. So we do a -1 out of 52.
Why do we keep minusing?
Because that's what the formula says, minus the ones that overlap. So what is 4 plus 13?
17.
Minus 1?
16.
16 over 52, which reduces to 4 over 13. Are we okay with that?
I
Now,
hope the test is like this and not like mine.
I know, I hope so too. I don't know, I hope the lady who makes it is not cranky. What is the probability of getting a black card?
Cucumber martini.
I don't know how many cards are black.
Yes, it's a bunch of martinis on your desk.
All right, what is the probability of getting a red card?
I don't know how many of the colors.
26.
There's half
26.
and half. If there's 52, half are red and half are black.
One.
So 26 are red and 26 are black. What is the probability that the same card is both
0.
red and black? 0. So it is 52 over 52, which is a big, beautiful, skinny one.
Yeah. That's what I got.
What is the probability of getting a card less than 4? So I have my A, which is considered a 1.
Oh,
what I
was thinking.
Whoa, that's.
Hey, I
That's
just
what I
did
was
3 and 2.
thinking.
That's
I
all I
got-
did.
No.
I mean,
So
I
here, your
didn't penalize
A's,
that.
your A's is considered a 1.
So that's 12 out of 52.
Your A's is a 1. So you have your 1, your 2, and your 3. 3 times 4 is 12 out of 52. What is the probability of getting a red card? 26 out of 52. Now, how many of these red cards are a 1, a 2, or a 3?
6.
6. It should be half because half are black and half are red. So half of the 12 are 1, 2, or 3.
Can we start this one over though?
So,
Can we what?
Start it over already.
I want to figure out how you got the 12 after you get the answer.
So cards less than 4 are your A, your 2, and your 3.
times that by 4.
So there is A, 2, 3s for the hearts, for the diamonds, for the clubs, for the spades.
Oh, okay.
So that's how there is 12. So
Okay.
3 times 4.
You really have to be in.
Yeah, that's what I got.
Yes.
It's because she's obsessed with that movie
Yeah, but
21. This is why she gives us.
And ace is high at me.
So yes, it is usually when you're playing poker, but sometimes you want that ace to be a 1 where you're playing blackjack and it's gonna come and hurt you. So it can. So what is 12 plus 26?
It's gonna be 32 over 52.
Okay, 32 over 52,
Which reduces to 8/13.
8 over 13. All right. This is supposed to say 210.
Oh, yeah.
I just changed the numbers on your notes. It was 250. On this one, it's a total of 210 people.
Okay.
So try this one. Take about 2-3 minutes to look at it. You don't have to answer the last one because I didn't like it last time either. Just A, B, and C. So, what is the probability that the person was satisfied with the results from the surgery?
45.
So, how many people were satisfied from all the surgeries?
160.
160 out of 210 total. So it reduces to 16 over 21. Now, this one's where, what is the probability that the person was satisfied given that they had knee surgery? So you only look at the knee surgery. How many were there?
45.
45 satisfied out of, so we do 45 out of 65. And it reduces to 9 over 13. Okay, so then try C again. So you have to look at how many had the knee surgery, which was 65, 45 were happy. So as you're trying to do C, don't tell me the answer, but you look at the people who had a hip surgery and how many people were unhappy.
A lot. I was unhappy.
You were unhappy with your hip surgery? So for this one, how many had the hip? 75? No, 70. And how many were dissatisfied? 15. And that reduces to 314. Now, before you go, because this is still, hold on, we're still working on the review, making sure, because as I'm working on this, I'm like, oh, they didn't get this problem. So just a little extra for 13, just kind of redoing it. So the probability of an even number, the way it was there, and the probability of a 6. So just changing it a little bit, the probability of A and B, because I'm going to change it. So what is the probability that those lottery balls were going to be an even?
4, 5.
It was 5 out of 10. 5 out of 10, right? I'm redoing 13. Now, what is the probability that one of a 6 in the entire 6 through 0 through 9? 1 out of 10. But what is the probability that the 6 is part of the even?
1 out of 10.
1 out of 10. So what is my answer?
5,
Which is
10.
1/2. So it's the same thing, but right now they gave you a 5. 5 is not even, so that's why it didn't have an effect. Oh, sorry, it's 1/2. Now, in the first paper I gave you, there was a problem. There you go, running off. Number 11. I don't have an extra paper, and it's an easy one, but what are the odds against Carl beating his friend on a golf is 9 to 5. What is the probability Carl would beat his friend?
5 to 9.
5 over 9.
Is it 5 over 9?
Or is it
Hey, did you do your?
4 to 9?
So the odds against Carl is what?
9 to 5.
9 to 5. Against
Against.
is 9 to 5.
Right.
So what are the chances that he is going to win?
4 over 9. 9 to 4.
What was the total amount that they,
Oh, 14.
there was 14 is the total.
Yeah.
So how many would it be that he's not? Is it the 9 or the 5? Which one is Carl?
9. Oh, okay. 5 over 9.
5 over 14.
Oh.
So the odds against him are 9 to 5. This is him losing, this is him winning. This is him losing, this is him winning. So when you just want to know his probability is, or it's the other way
Be
around.
9, 14.
Yeah. No, but this is actually
So he lost.
the odds against Carl beating his friend.
So this 5, 14.
Oh,
So this is the friend
yeah.
and this is Carl. That's the way it should be. So it is 5 over 14. Sorry.
All right.
5 over 14. You're going to have a question like this. Oh, let's do this one, number 10. Look at it. It's on your paper, but if you don't have it, just look at it right there. and that's gonna be the last one. Is it? I don't know. A number is labeled 1, 2, 3, 4, 5, and 6, and it's taught. What is the odds in favor of a Q showing a number less than 3? How many of these are less than 3?
2.
2 over 6.
2, 4. Because it's 6 numbers.
So how many numbers are less than 3?
2.
2, which is what? 1 and 2?
2.
Not
Two,
far.
but it's not, do you remember the formula for the odds?
Yeah, it's gonna be 2 to 4, and it's gonna be 2.5.
It's 2 to 4. How did you get 2 to 4?
Because that's the total number
The total number of what?
of your chances are gonna be 2.
Oh.
And then the total of it all, the outcome is gonna be 4.
Where'd you get the 4 from?
Because 4 left, 2 plus 4 is 6. The 6 sides on the die,
Mm-hmm.
so it's 2 to 4.
It is 1/2.
So because the top is the event to occur, and the bottom is the event of how many times it fails, like how the possibility of it.
That it's not, yes. So this is success over failure. Do you remember that? Yes?
Chance.
Chances. 2 are good, 4 against you. So you might have something like 2 and 11 on your test also. Alrighty.
There'll be bonus.
I don't know about that.